Very glad to be here. So when 6 years ago I got introduced to Golang, I used to work as a Java developer then. I looked at the Golang syllabus and I thought, hey, it's not much. I'll learn the syntax in 2-3 days, and next 2-3 days I'll learn some semantics, and within a week I'll be an Golang expert. But I was a fool. Why I'm saying that? I'm going to explain in the next part of my presentation. The reason I said that, because earlier I thought that when I got introduced to the world of Golang, I thought that any language is just syntax and a bit of semantics, but I was so wrong. Any language is not just syntax plus semantics, but it is syntax plus semantics and the idioms. So what I was missing there was the idioms, the idiomatic way of writing Go code. That's why it took me 6 years to be proficient in Go, and still today I don't say that I'm an expert in Go. Let me give an example why idioms are important. At EPAM, my designation is lead software engineer, but whoever created this Developer Summit website, they mentioned my designation as principal software engineer. At EPAM, we don't have a designation called principal software engineer. Perhaps this person is more used to the title principal software engineer. This is where idioms come into picture. It's just a difference between buddy and mate, right? They are doing mostly the similar kind of work, lead software engineer and principal software engineer, but there is an idiomatic difference in that. So I'm going to walk you to 7 examples which I found along the way of my Golang journey. They are mostly the symbolic examples, so the experts and maestros in the audience can judge those examples thoroughly. Just keep your disagreements till the end of this presentation. We'll have some time for Q&A towards the end of the session. Number 7, treating errors as exceptions. So in Java, we are used to create a try-catch block around every piece of code, and we used to throw an exception. So try-catch block will catch that exception and handle that exception. So when I started learning Go, there was defer, panic, and recover. I thought it's easy. It is just like try, catch, and throw, right? Just defer, panic, and recover. So I used to write error handling in Go something like this. But I learned the hard way. In Go, it's not idiomatic to handle errors in this way. In Go, you don't treat every error as an exception. So as a Java developer, I used to write panic at the encounter of every error, but that was not the case with the idiomatic way of doing it is returning error as a value and handling that error. So in Go, panics are typically reserved for only unrecoverable errors, like accessing out-of-bound array indexes or nil pointer dereferences. So divide by 0 is not an exception in Go. It's an error. It should be handled as an error. It should be returned to the calling routine and then handled. Misusing pointers. As a Java developer, we were used to using references, not pointers. We were not known of pointers much when we were doing Java. So when I learned about pointers in Go, I thought it is similar like references only, right? So I decided to be an oversmart and wrote a code something like this. So I wanted to modify an object. I passed that object with reference to this chain name function, and I assigned address of an object with a modified name. And the output I got is before and after was same. The reason is pointers are are not the same. The way how you do it in Go is like this. You dereference the pointer, you assign, and you assign the value to the field of the struct, not the other way. So for a person who is getting into Golang world along the way, it is important to know that pointers point to memory addresses and references point to objects. The next pitfall I encountered was overusing object-oriented design. So as a Java developer, I used to let's say like if I had to calculate an area of rectangle, what I would do is I would create an object with data members like length and width, create functions for that object. I'll calculate the area like length into width. I'll write getters and setters. When I got into Golang world, I followed the same practice. I created an object, created getters and setters for every data member for that object, and then I wrote an calculate area function where I passed a pointer receiver, because I've just learned the pointers, right? But when I learned in depth, what I found is I could have done it better with idiomatic Go way, with much less code and much less memory usage, right? So in Go, if the fields are exported, you don't have to write getters and setters for those fields. You can directly access those fields and set them and get them. Only for the fields which are not exported, you use getters and setters. Also, the pointer receivers, it is not necessary to use pointer receivers for every method. Use pointer receiver only where they are required. With that, what you will do is you will improve the performance of your code, because pointer dereferencing is a costly operation. So the takeaways here are: no need to define getters and setters for exported fields, and do not use pointer receivers unless required. Fourth pitfall, trying to impose Java style inheritance and polymorphism in Go. Go does not support inheritance. So like in Java, we are used to inheritance, like we are used to extending classes and reusing code, right? So I thought I can be clever because I know pointers, I know references. I can be clever and make Go support inheritance. So I did something like this. I created a struct animal, and I created a struct dog, and I made animal member of dog. And then in main, I created a reference of dog, and I called a make sound function, which is bound to animal type. But later, I realized that I could have done it better with much efficient way. In Go, it is better, it is always better to implement interfaces than trying to extend functionality of objects by embedding them into the structs. So people who are familiar with Go might know about the Go struct embedding, but it is very important to note that embedding struct in Go primarily is for composition, not for inheritance. So Go does not support inheritance. We should not try to make it support inheritance. Misusing Go routines and threads. So being familiar with the Java multi-threading system, what I did is I created a Go routine, something like that, where I use this runtime.goshed primitive. This primitive does, what it does is it yields processor explicitly for other Go routines or other routines to use it. But that is actually not necessary in Go, because Go runtime scheduler handles scheduling of Go routines very efficiently in a user space. What it does is it actually multiplexes between number of Go routines to the number of OS threads. And as a programmer, you don't have to worry about it. You don't have to explicitly call this runtime.go shed primitive until and unless necessary. In my experience so far, I have never had to use this runtime.go shed primitive. Second pitfall was using Java concurrency patterns in Go. In Java way, let's say if I had to create a producer-consumer problem, producer-consumer implementation, I had to increment a counter, right? If I had to increment the counter, I'd use a synchronize method to make it thread safe, because it's a shared variable in this particular scenario. So what I did is, because I knew pointers, because I knew synchronization primitives like mutexes in Go, what I did is I created a function something like this. I mimicked the behavior of the synchronized method in Java and created like this. There is nothing wrong in this per se, but it is not an idiomatic Go way of doing it. How you do it in Go is you do it through channels like this. You do not create a method to make your shared variables thread safe, because the philosophy of Go is do not communicate by sharing memory. Instead, share memory by communicating. First pitfall I encountered, pitfall number one which I encountered after this was inadequate understanding of channels. Now, because I knew about channels, because I knew about synchronization primitives, because I knew about Java patterns, what I did is, while creating a producer and consumer using Golang, what I did is I made use of channels. I created channel queue. I was writing I here on this channel where producer was producing, and my consumer was reading from that queue here. But the only problem with this, my producer is the faster one and consumer is slower one. So my producer always had to wait while consumer is busy waiting or busy doing something, because it's a slower consumer. Because whenever you are using unbuffered channels in Go, they are blocking calls. They block the receiver every time. So how can I solve this? You have to make use of the buffered channels in Go. If you make use of buffered channels in Go, you would get much better performance using channels only. For example, in this example, my execution time is 5 seconds for the same task. In this example, my execution time is 10 seconds only. So these are the common pitfalls I encountered, and I learned along the way how to solve them. These are only 7 pitfalls I shared with you guys. There are much more. There are much more things you should know about Go while writing idiomatic Go code. We can always reference to the Go native documentation at pkg.dev to understanding idiomatic ways of doing this. You can access full article about these common pitfalls at this location. This is a Medium article. You can scan it. Whoever is interested in this, you can scan a QR code. Hope it's done. You can connect with me on LinkedIn on this QR code if you are interested in this particular topic. I do work with budding Gophers. I do head a Gopher community at EPAM. I do write about Go. I talk about Go. We do arrange meetups, and we are the people who love to talk about Go and cloud native applications. So if you want to join our community, you can connect with me.